All right, so we're going to take these a starting point of a class diagram, right? This one, and we're going to criticize it. We're going to revisit some of the pieces of text, the verb phrasing, and also look at it alternative ways of rewriting it, and see how it affects the class diagram. So let's see. We're looking for instance, one of the steps of analyzing the class diagram is to see if there are relationships, right, that might have a better representation. So let's look at this. So we have the student record, right, the student class diagram, the student class is way up there. It looks like it has relationships with quite a few things, right? It has relationships with grades, relationships with the department, relationships with sections, with the year, with permit. It has quite a few relationships with lots and lots of different places. The majors in, references to the department, the enrolls in, references to section, the enrolls in, and has enrolls in and has. Okay, so it looks like enrolls also has relationship with the course, right? So it looks like the student enrolls in a section, but then also there's a relationship with the enrolls in the course, right? So this might be a redundant or different ways of representing the same information, which we would like to avoid. Okay, for instance, we could have interpreted or read the text as follows, right? We might say that a student enrolls in a course, and a course has many sections. This could have been a very, a very legitimate way of representing the class diagram, right? The student enrolls in a course that's actually taken from the text, and a course has sections, right? So this could be a completely legitimate uh, thing that we might have come up with, a very naive way of we could have represented this, right? But when we start thinking about it, we notice that something that is not captured here is that where is the student enrolled in, right? Like we know that it's in that course, but we know how that course has many sections. So really, the student is not enrolled in a course; it's actually they're enrolled in a section. Right? So we don't know. There's no capturing here of which section are they in. So I know they're in the course, but I have this 2, 3, 4 section. Which one? And it's not captured here, right? So even though the class diagram looks fine, right, and it is indeed capturing some of the information, it's missing, right, a crucial question that we might want to answer. What section are they in? Notice if that query were not non-existent, right? If never the dean or the registrars wanted to ever ask whether a student is enrolled in a section, right? This diagram would be perfectly fine. There's nothing wrong with this diagram. But once the question comes in and saying, wait a minute, what section are they in? This class diagram is inadequate. So the inadequacy of a class diagram, right, is subjective to the kinds of questions and queries that you want to be able to answer, right? So it's all by itself. There's nothing wrong with it, right? Only when you are trying to query, it says, oh, that information is not captured in this class diagram, right? So now it's inadequate, right? Um, so we're looking to exhaust every path, make sure that all the queries that they're being able to answer, want to be able to answer what kind of grades this student got in a particular semester, right? So that's a legitimate question. Is that captured in the database? Maybe not, right? Did they transfer from once did they drop a section and they enroll in a different section? Is that captured? A history of having unenrolled and enrolled? No, we're not capturing that at all. No history is being captured, right? So again, depends on the queries is what defines whether something is adequate or not. A couple more things here. It says receives, right? A student receives a grade, but again, we don't know that actually that grade was for a section, right? Not for the course, right? Also, the professor assigns a grade. The professor doesn't assign it to the student; they assign it for a section that they were enrolled in, right? That also is not capturing here. We don't know that. So one of the things that we might want to ask is, well, how do we end up with this, right? I mean, I read the text, and when I read it, this made sense to me. And this is very, very common. One of the things that we might have gone wrong with is that we oversimplified, right? That we tend to read phrases as binary relationships, right? We read a noun, a verb, and a noun, right? And somewhat just skim over and not realize that actually it's a verb phrase where there are actually several nouns, 3, 4, 5 nouns that are tied together with multiple verbs, right? So for instance, we misread student receives grades and kind of missed the fact that if we read a little further, it says that student receives a grade for an enrolled section, right? Or this one, professor assigns grade, professors assigns grade to students in their sections, right? Sometimes these verb phrases might not be nicely in the same sentence. There might be a sentence here, maybe a sentence there, right, later on. And it's our responsibility to tie them together. Say, ooh, these two go together, right? These relationships go together. Once we cut and paste and bring them all together, we realize that actually there's 3 nouns that are related here, right? 3 or 4 even, right? And that something that we thought was a binary relationship might be a tertiary relationship, a 3-way or 4-way relationship, okay? That there might be 2 or 3 or 4 nouns together. A student receives a grade for an enrollment or a section, whatnot. So here's an example, right? We might say that students receives grades on multiple grades, right? And we want to capture the fact that it's for a section, right? That if you give me a combination of a particular student and a particular section, there can be only one grade for that combination, okay? Conceptually, we could just capture it like this, and we would be fine, right? Just a dot, and says these 3 nouns are somehow related. Obviously, we can't implement that in relational databases, right? So we have to go a little further and reify it, right, into a concrete class or concrete table that can actually hold the relationship between all these 3 nouns. So there would be a dedicated class that has relationships with all the other 3, saying, hey, this particular student in that particular section got that particular grade, right? We'll come back to this later, since there's several things that are lost coming from the conceptual model to the concrete model. Right here, we're kind of enforcing that you only get 1 grade, right? But oftentimes there's no way to enforce it when you reify, of saying no, there's only 1 grade, that perhaps with primary keys and combine primary keys, but there's certain things that cannot be enforced when you go from the conceptual to the concrete, and we'll talk about that in a minute. The 1 here and the star, right, meaning that there could be any number of combinations of students enrolled in many sections, and one section having many students. Any one combination of these 2 gives you the particular grade that combination gives. Also notice that this obviously this 1 table here eventually is going to become our enrollment table, right? It's basically that's where we're going, right? We're going towards the class diagram that we already saw at the beginning of the semester, right? We're gearing towards heading towards that way, right? We have the enrollment table, right? That associates these three concepts. Reification is just a term that means that to make concrete something that is conceptual, right? But cannot be actually implemented unless you give me an actual class, right, or an actual table that can be implemented in whatever particular framework, particular technology you choose to implement it in, right? So our first transformation is to combine the grade, the student, and the section, right? And combine those relationships with this grade assignment in the middle, pointing to these grades, the sections, and the student. Also, we tied it to the professor, saying who is assigning that, right? That grade to that particular student, to that particular section. A couple other things that might be wrong with this class diagram. All sections a student is enrolled in, right? So it looks like we have this many over here. Student enrolled in a section. So it looks like there's a many over here, but we kind of have already that information. We could answer that question by joining together the student, the grades, and the sections. Like that, we can also answer that question by navigating this way, right? We can list all the sections that a particular student is enrolled in, or from a section we can display all the students enrolled in that section, right? Which is basically this relationship over here. So in that fashion, if we're asking, I want to know which students are enrolled in what section, now, because we want to answer that, this relationship is now redundant with that. If we weren't asking that, then the relationship would not be redundant. Okay, it's what the requirements ask us to do is that defines whether something is inadequate or redundant. So we're asking, what students are enrolled in what section, and that kind of tells us, ooh, we can go one way or another, and we should remove one or the other. Right, so just examples on how you could navigate with foreign keys and primary keys. So yes. Yeah, there's no way to implement many-to-many, at least in relational databases. In non-relational databases, we can, right? Because they could be just arrays, and you can have an array of foreign keys. But in a relational database, you can't, right? So you only have one foreign key, and so the only way to represent the multiple of it is to have a mapping table, right? Yeah. So right. So again, some of these steps that we're taking is based on the fact that we know that we're going to represent this in a relational database. Yeah. Right. So here this is a snippet of what we had earlier, where we had the fact that a professor is assigning the particular grade, which is fine, right? But if we start digging a little longer, we say, wait a minute, but it's only one professor, right, that is teaching this, right, for that particular section. So I mean, who else is going to assign this grade? Only that professor is the only answer, right? So if we make that a business rule where there's only one professor in that particular section who's responsible for assigning the grades, then this assigns is redundant, right? I already know that if I know the section, then I know the professor that teaches that section. I mean, who else could assign this? So there's no point in also capturing this one-to-many relationship of who's assigning this. Now, if there were multiple professors, perhaps then you might want to capture that. Which professor gave you that grade? Which TA did you go to? Who graded you? Then perhaps we might need that, right? But in our case, we have one professor teaching one section, so then in that case, this assigns becomes a redundant relationship. Here, anytime you see cycles like this, and there'll be plenty of cycles, these are also always suspect. It says, well, depending on the questions I want to ask, can I answer it in multiple ways, right? Again, remember that we're gonna drilling this for quite a bit. We want to remove redundancy. We want to remove redundancy. We always keep saying that redundancy breeds inconsistency, right? One of the things that we like to avoid is whenever we're updating something, we're always updating just one record. There's no need that we want to avoid having to update two records, because maybe one could fail. That we were able to do one, but maybe not the other, right? Or inadvertently, because of some programmatic mistake, the two values that logically should be the same, right, somehow might be drifting apart, right? Just like my example of the two watches, right? That logically it should be the same, but for other reasons they might be drifting apart. So here's yes. Yeah. Right. Right. Yep. Yeah, exactly. Yep. That would make it unique for that one particular section combination with that professor. Yep. Yep. So here's another example where you might have a cycle, right, and it could be suspect, right? It could be that if I ever could navigate from one table to another table, it could be that depending on the questions I want to be able to answer, one of these paths might be redundant with the other path, the other existing path, right? And again, it depends what the question is. The question might be, what each student majoring in, right? That might be the question. It says, well, I could certainly answer it by following the relationship between the department and the student. I could say, well, give me a student, I can follow what department they're enrolled in. Yes. So one of the questions might be, so can I answer the same question following other paths, right? And if you follow along with the student to the grade, to the section, to the course, by the time you get to the section, right, there's no way by the time you get to the course, right, there's no, you've lost which particular student is enrolled in what, right? So there's no direct, relationship, right, between a particular student and the particular department that it might be in, right? Because you might have multiple courses for the department, and there's no one-to-one relationship to the department. So in this particular case, you want to be able to have both, right? Both of them, because they're not for that particular question, right? So if the question changes, it might be redundant, right? Right. So you iterate over all the different questions that you want to be able to answer, all the different paths exhaustively, saying, can you answer those kinds of questions differently, following different paths. Here we have removed the assigns, right? We have removed the enrolls in without the between the section and the student. Let's do a couple more. Here we have right. So our algorithm does not deal with a strong. I'm sorry, weak, right? Where both relationships are star or 1-1. It only deals with one-to-manys, right? Like and so what if we had instead of just one department and many students, what if we had like many-to-many? What would we do? Where you might have one student majoring in multiple departments, right? Or multiple majors. So the strategy that we're going to follow is that we're always going to convert this, right, into two one-to-many relationships, right? For instance, if we have a many-to-many, we'll put a mapping table in between, and now the algorithm works. Right? The algorithm, we're back to the same algorithm, which deals finally with just one-to-many relationships. Okay, we reify it into two one-to-many relationships. Remove the many-to-many into two one-to-many relationships. Let's see a couple other examples. If something that might make sense, when we started off with the requirements, and perhaps the requirements was that a student can only major in one department or one college, then it made sense to just keep one major GPA, right? You have one GPA for the whole, that you're going to graduate with. That's the only GPA you could possibly have because you're graduating just in that one department. But later on, as the college progresses, the university progresses, and now it allows you to have multiple degrees, we might be tempted to just make this many-to-many relationship, right? And perhaps with its mapping table and reify and whatnot, and leave it at that. But now, right, that one change, right, has repercussions in other places, right? That we were also keeping track of this information. For instance, we would have been keeping track of the major GPA. But now we have to keep track of multiple GPAs, right? One per the department, right, or per college, and perhaps at first it might look enough to just have a many-to-many relationship here, right? The problem here is that we don't know, what GPA for which department, right? We just know that the student has multiple GPAs. So how could we keep track of that? Somehow, this major GPA should move over here to somehow keep track of that this student in that department get this particular GPA, just like the grade that we saw earlier, right? That were assigned when they were enrolled in a particular section. Now a department is just a bigger version of that section, yes? So we conceptually might capture like this, that a combination of a particular student enrolled in a particular department has one GPA, and obviously we'll need to reify that into several one-to-many relationships. right? Each multiple relationship is converted into a binary relationship, a one-to-many relationship, which is fine. This will work. But what if you could further say that you could be undeclared, right? A student who has not declared their department yet, right? Some universities, I think this university allows it, right? Maybe the first year or first semester, where you don't declare your major, right? So maybe you're not in any department, right? So this now becomes a conditional relationship where maybe there is a relationship, maybe there isn't, right? So what do you do with this major GPA over here? Does it exist? Maybe it doesn't exist. Maybe it's enough like this, right? If it's only one department. But again, what if you're enrolled in many departments? If you're enrolled in many departments, you have to bring the major GPA again, right? And then capture it as the entire set of records that relates the department with the major with the student. The whole thing is optional. It could just not exist if it's a 0, or if this is 1, then you have this record entry that points and relates to the department with the GPA, right? This record, the whole record over here could either exist or not, telling you that there's one relationship for a department and the major. Okay. So week to week, let's see, permits. So let's look at the permits over here on the left-hand side. Looks like the student could have a permit. Maybe they don't have a permit. Looks like it's not obligatory. And perhaps some folks might add additional requirements saying that, hey, not only students can have permits, but maybe even staff can have permits to park, right? But the staff have the benefit that their permits don't expire, whereas students expire every semester and they have to reapply every semester, right? So maybe that's a requirement that's added here. All right, students might have just one permit and it expires, whereas staff don't expire. So how would you capture that, right? So here you have a 0 to 1, where the whole thing might exist, might not exist, right? Maybe I have a permit, maybe I don't have a permit, and here it might expire or not expire depending on whether you're staff or not. Right, so here the expiration date only is available through the students, but the expiration should exist only if you're a student, but it should not exist if you are a staff. So here we have the expire existing if there's a relationship between the student and the permit. Even if there is no permit, then there's no point in keeping track of any expiration date, right? So the whole thing would disappear if there is no permit whatsoever. If there is a permit, then there would be a record that would capture the relationship between the student and its expiration date. Right. So week to week, we remove them in the algorithm so convert them into one-to-many so that the algorithm works. Strong relationships, one-to-one, where you're a student and you have a permit. You could argue, right, that one-to-one relationships. One of the arguments here is that if this is a one-to-one, why not just embed the entire thing inside of the students, right? Just bring all the variables, all the fields, right, and just bring them into the student. Right? I mean, that would be a legitimate argument, right? Since the permit doesn't exist if the student doesn't exist, if the student exists, then the permit must exist, right? This is what this is saying, right? But nevertheless, it's always a better practice to just keep them separate, right, as two different concepts, even though there is a one-to-one relationship that one must exist if the other does exist. Right, we could merge the classes together, so that certainly is an option, or better just leave it in a separate class, and just have a foreign key primary key, foreign key that it's also a foreign key that relates the two records.
Hi everyone, Jose here. Please remember to subscribe and like the video. And if you have any questions, please leave a comment down below. Thank you.